Hey gang, this is 8 Bits of Brain with MalWerewolf, and I'm here today to talk to you about the Autobreak API script. If you go to our GitHub page, linked there, and then the Autobreak API repo, you see a description, and it's pretty simple. It just tells you straight out it's going to parse through a Windows portable execution, PE, and it's going to look at the import table, loop through the import table, and attempt to set breakpoints on all the imported functions. The idea behind this is twofold. First off, very quick, easy, high-level triage of a particular sample. You see every API call that it's going to make. Well, excuse me, most of the API calls it's going to break because it may be using load module and get proc address and so on and so forth. But in general, you get the point. And the other thing about this is very useful for someone who's just learning to debug, especially using immunity and or Ollie. The idea being, if you're not familiar with going to the names window and you're not familiar with the functions that are in there and you just don't know what tickles your fancy, well, you take a look at all of them. And then, peruse the Microsoft Developer Network MSDN library and get a feel for what the functions are really doing, and so on and so forth. So, all you need to use this bad boy is PE file, and you can get that using pip. So, there's your install. And then you simply copy the Python script to the PyCommands folder of your immunity installation directory. So we're going to go over here. Whoop! This is one of my Windows XP VMs. You'll see it's running Windows XP Service Pack 3. And you'll see our sample down here, and here's immunity over here. Well, let's take a look at the script before we go anywhere else. So we're going to go into our immunity install folder, and you'll see PyCommands is a folder in here. And in PyCommands, what we want to do is just copy the file. So in here, I've already copied mine. Autobreak-api.py. Ignore this file here. In fact, I'll even delete it. That's compiled when the program is run in immunity. So anyways, if you take a look at this guy right here, we'll open it with idle. Alright, first thing we're doing here is we're instantiating the debugger class. So IMM for immunity is going to be our debugger that we're working with. Next thing that happens is we go down here to main, and main's going to do something very simple. It's going to check to see if there are any arguments provided, and if there are, it's going to complain. Say, hey, stop it. And then it's just going to exit. However, if there are no arguments, it's going to run setup, which is what we want it to do. If we go up to the top here, we see that setup starts to write to the immunity log. First thing it does is it just puts its version name, well, its name and version. And then we grab, and then we, right there, the debugged PE name. And then right here, we're getting the path to the debugged PE. So those are both displayed in the log. And then finally, we're instantiating what we really care about. We're using pefile.pe to create the object directly to the PE that we care about that's currently loaded in immunity. And then we're simply passing that to the main or primary function called parse_pe. If you go into parse_pe, you'll see it's documented here for you, but all it does is it loops through the import table, and for every import that it finds, it's going to first create a string where it's going to get the DLL name. So the DLL name is going to be, for example, kernel32.dll. We don't want the .dll, so we're going to just regex that out using regular expressions. Anyways, if we're able to get that, what we're going to do now is set another string called current breakpoint, and that's going to be the DLL name along with the import name. Basically what we're doing here is instead of having, for example, kernel32.dll/function name, we're just taking the .dll out of there, and we're keeping the string. And we're calling that current breakpoint. Then what we do is we try to get the address of the current breakpoint. If we can get the address, that's good. If we can't, that's not good. So we look to see if the address returned is above 0. This function, getAddress, will return -1 if it could not get the address of the function. Even though a function's in the import table, it might not actually be imported. And the other thing is it might not even be on the system. So, and the third thing, excuse me, is that it may not have access to that memory space for whatever the heck reason. So if we're able to get the address, well, then we just set a breakpoint on the address, and then we log it. Cool. If we're not able to get that, well, then we just log the fact that we were not able to get to it, and we designate that with address error. So the log will just be full of breakpoint set and address errors. Hopefully it's not full of address errors. So that's the script, short and sweet. Now the sample that we're using, tnnbtib. We're going to go over here to my other screen. And we're going to take a look at Virustotal. This is the MD5 for it right there. You'll notice the detection rate is 48 out of 51. Yeah, that's pretty high. So this is very well documented specimen. This actually was developed for a particular SANS course, one of their RE courses, 4, 5, 6 something years ago. And so it's been passed around the internet quite a bit. This is very well documented. So if you want to look this up after and even use the script to go further than we're going to go, that's awesome. I'm not so concerned with the sample right now as much as I am with the script's functionality. So let's go back over to the screen. You'll see that by default, this little sucker's packed. It's packed with UPX. Now, setting breakpoints on functions that are imported won't do very good for you. It's not going to do a whole lot for you, excuse me, if you're using a packed executable. Most likely because you're just going to stop on all the calls to, get proc address and load library, and that's, you can still debug that way, but that's boring. So we're going to unpack this particular guy. Do a UPX-D. Bam, unpacked. And now we're going to take this little sucker and drop it onto Immunity Debugger. And it loads up. Okay, now I'm just going to press Control-N on my keyboard. And that brings up the names window, the function names window, basically. This shows you all the different functions that are in the imports list. So this is what we're going to be working with technically. I'm going to go back to the CPU window, and now I'm going to run Autobreak API. In fact, before I do that, let's go to Window and Breakpoints, and you'll see that we have no breakpoint set. So down at the bottom left here in the command line or the console, whatever you want to call it, I don't know the official name, but whatever. We're going to put a little bang right there, and then to execute the script, you just type the script's name. So Autobreak API. Boom. It says here, hey, I'm done. Check Immunity's log. So we go over here, and we check the log, and there's our output. So there's the PE. There's the PE path, and we were able to successfully set some breakpoints. We had some problems here. We also had a problem with almost all of the WinSock32 functions, but that's okay because this specimen actually uses WinInet, so whatever. And you'll notice that this will get noisy. For example, memory allocate. I mean, come on, it's just going to be firing off all day. Sometimes also a virtual alloc is triggered. I mean, that's just going to be going off all the time for memory operations. So in that case, you can go to the breakpoints window over here, and you can disable some that seem like they're going to be chatty. But in general, if you're just not familiar with any of these, just let it ride, see what happens. So that's actually what we're going to do. We're going to go over here to the CPU window, and we're going to start the program here. You'll notice it's currently paused. Very bottom right-hand side shows what's going on. This is the top of our stack right here, so any call that we're going to break on, the call is going to be here. And sometimes you're going to see the various arguments listed also in the stack, which is usually how functions are called. And we're going to be paying attention up here at the top right-hand side, also looking at some of the registers. So what we're going to do now is just hit F9. F9, when you're running Immunity or Ollie, is run. It actually is run till next breakpoint, basically. So we're going to just hit F9. All right. Entry point F9. All right, you'll see here's the name of the function that it's being called. Memory allocation. Yeah, don't care, really. So I'm going to hit F9 again. Memory allocation. Don't care. So we're going to hit it a couple more times. Now it's freeing up some memory. Get module handle. So it's getting a module handle for kernel 32. We do it again. Getting proc address. So it's loading another function here. But here's something important. Create file. So create file, by the way, it's called create file, but it can also read a file. In fact, that's what it's doing here. See, access equals generic read. That means it's literally reading the file. It's not actually writing anything. But what is it reading? Well, it's reading its executing application. So the process is running from there. And then we hit F9 again. It's getting the file size. So it's trying to see how big that file is. And now it's setting a file pointer. So basically we're creating a file handle here. And then now we have read file. And then close handle. So we basically create a file handle to the executing application. Memory allocation, get Windows directory. So by the way, get Windows directory just ran. Okay, so it wanted to know the Windows directory, and it's already using that right here. This is string concatenation or string cat. Stir cat will basically just put some things together, strings, and combine them. So we're going to be adding a slash onto C Windows. C Windows, by the way, was the return from the Windows directory function that we just had. Oops, ignore that. Alright, memory allocation, string cat. Okay, now what we're doing, we're going to do string cat. We're putting the program name onto the Windows directory. The resulting string is going to be C Windows and the name of the file. What we really care about is this guy right here. And now we're doing a string comparison. We're comparing where it's currently running from to this guy right here, the directory from which it wants to be executing. It's not, so what's going to happen? Well, if you were to pull this up in IDA or something, you'd see the jump tree, but it's going to basically take different action based on whether it's running out of the Windows directory. Right now it's not, so what's it going to do? Well, it's going to fix that problem. So it wants to run out of Windows and the Windows directory. And see here, we're doing copy file, and we're going to copy from where it is to where it wants to be, the Windows directory. And now we're writing the file, and then we're closing the handle. Now, we see here, it's creating a registry key. Here's the fun part. Where's it going? It's going to current version run, so you probably know what's happening here. It's going to create persistence. We hit F9 again, and you'll see registry set value EX, ASCII version. So what is it doing? Well, it's setting a key named update, right? So what's going to be in there? Well, you have to look up here. So currently in the ECX register, we have the executables location, at least the new location where it just copied itself to. So it's creating persistence. It's going to run on startup every time, and the key name is update, so you can look in there and find that later. And we hit F9, and now what it's going to do is create a process from that new location. So create process, it's creating a process from there. So it's running from its new location. Well, what's it going to do now? Well, it wanted to run from the Windows directory. It wasn't there. It copied itself to that location, and now it's just closing up shop, literally. So it's closing handles, registry close key, it's closing the registry, closing handles, exit process, close handle, and we're just about done. It's just cleaning up, basically. Freeing up memory now, and terminated. So down here, bottom right hand side, it is terminated. Is it really terminated? Well, no, because it created a new process out of the new location. So if we just open up the generic old task manager and we take a look here, you see that it's running. Oh. So where is it running from? Well, it's running from that new location. Let's go attach to it. I'm going to go to File and go to Attach. And we can go down here and we see that currently we're attached to this guy right here. Let's make this window a little bit bigger. There we go. Alright, there it is running right there. tnbtib running out of the Windows directory. So we hit Attach. And you'll notice here, when I go to breakpoints, we have no breakpoint set because as far as immunity is concerned, we just opened up a new executable. So we're going to then run Autobreak again. When we run Autobreak, we see that once again we have the same breakpoint set. And we hit F9. Oh, it's already running. That's right. Okay, well in that case, let's just stop the process. Ignore that. Do over. We're going to stop tnbtib. Oh, I'm going to stop it itself because I was attached to it. All right. Let's load it from the Windows directory. So here we're in Windows, tnbtib open. Autobreak API. And then we go over here to breakpoints. We have everything set. Let's go over to the CPU window and start hitting F9. Okay, so memory allocations, freeing up memory, get module handle, get proc address. Now it's going to read the file in again. File size, file pointer, and then close the file handle, and then we take a look over here. We're doing our string concat. It just got the name of the Windows directory again, and what we're doing now is we're looking, this is once again comparing where am I running from compared to where I want to be running from. And at this time it's going to succeed. So when it succeeds, well, what's it going to do now? Well, at this point I'm going to digress because our point here is not to go through this entire sample, it's just to show you how useful this script is. I'll stop right here. At this point, it's calling get tick count. It may just be seeing how long it's executing, or it might be doing anti-debugging because your tick count's going to be a lot higher when you're stepping through the program. But we're going to stop here. So the idea is that you can get a very quick high-level triage of the sample. In this example, we saw that it was writing itself to the Windows directory and then running from there. And if you're not familiar with basically how various functions work or what they do, it's very simple to set the breakpoints and then go look to see what arguments are being passed to each and every function. So that's it. Again, my name is 8 Bits of Brain with MalWerewolf signing off. See you again.